In this lesson, we are going to focus on the interpretation of the trigonometric graphs. We are going to divide the lesson into three sections. Firstly, we're just going to look at questions that ask for the coordinates, then distances, and then finally the inequalities. So in this first example, it says write down the equations of f and g. So we have seen, if this is f and this is g, we have seen in the previous lesson actually how to do this. And first of all, when we start with f, let's just identify which one it is. You can see it has the shape of a sine graph. Now also, we want to see where its minimum point and its maximum point is. It's from 0 to 4. So that's 4 units. If I go to the midpoint between the minimum point and the maximum point, I am at 2. That means the graph has been shifted up 2 units if that's my midpoint. And then also from 2 to 4, that's 2 units, meaning the amplitude is 2 units. So the equation of f of x, would be equal to 2 sine x plus 2. And then for g, this resembles the cos graph. And we can see it goes from -2 to 2. So the midpoint is still at 0, meaning it hasn't shifted up or down. And then we can see it goes up to 2, obviously, so the amplitude will be 2. So gx is equal to 2 cos x. Right. Then for b, what are the coordinates of the turning points? Now, coordinates are quite easy to find because it's simply just going to be our x values and y values at those specific points. And we've been doing this since grade 9. Now, the coordinates of the turning points, my turning points are C, E, and D. So for C, the coordinates, the x values are 90, and the y value is 4, so that's 90 degrees and 4. Then this turning point at E is the x is 270 degrees and the y is 0. And then finally, the turning point on the g graph, we have the x value as 180, so that's d is 180 degrees and the y value is -2. Right, so for C, it says what are the coordinates of the x-intercepts of g of x. So x-intercepts obviously are where your graph cuts the x-axis. So you can see the first one here at I, and the coordinates for that will be at 90 and 0. And then the next one, it cuts again at E, and the coordinates, as we saw, sorry, was 270 degrees and 0. And then D, it says read from the graph the coordinates where f of x is equal to g of x. So what this means is, where does the graphs lie on each other, or where, at what point or points are they equal to each other? So we can see that here at H, they cut each other, they intersect each other, and then the one shoots up and the other one down. And then here at E again, they intersect at this point of E, and also again at F. So simply going to write down those coordinates. It's 0 and 2 for H, and then for E we've seen also as 270 degrees and 0, and then finally at F is 360 degrees and 2. Okay, so next up we have the distances, and we are working again with the same two graphs as we did previously. In this example, it says determine the length of JK. So let's just see where JK lies. We can see it over here. And if a line is parallel to either the x-axis or the y-axis, it's quite easy to find its distance, given that you have the coordinates as well. Now we can see that K, the coordinates for K will be at 315.5. So this one, this distance over here. Now, just a point to take note of, the sketches aren't normally drawn to scale. So you're going to have to just establish it. Either they will give you the coordinate, otherwise the easy way to establish that it is lying on the y value is a half is just to substitute the 0.315 into your equation for sine x, because that point lies on sine x, to get the y value. In any case, so since this y value is 0,5 and that point's y value is 0, we can see that the distance between these 2 points, given that the line runs parallel to the y-axis, is just simply 0,5. So jk is equal to 0,5. Then the length of d. Now g lies on f and d lies on g. And then also we see that both of these x values are 180. So now to read off the y values, we see g is 2 at 2 and d is at -2. So the distance between the two, the distance from -2 to 0 is 2, from 0 to 2 is 2. So the total distance will then simply just be 4. So d is equal to 4 units. Then it says use a calculator to determine the length of ml, where ml is f at 225 and minus g at 225. So that's this distance. Now, the first thing we're going to do is actually just to find, because in this one we're given the x values, we first have to find the y values of those points. They aren't necessarily exactly at a specific point which is easy to read off from your graph. So then finding the y values, we substitute it into the equation of the graph. So f of 225 is equal to, so f's equation is 2 sine x plus 2, so 2 sine of 225 degrees plus 2. And then we're just going to type this into the calculator. So we have 2 sine of 225 plus 2, and that gives us, let's just say to decimal places, let's say about 4 decimal places to keep it accurate, 0,5858. So 0,5858. All right. Then at g, at that x coordinate, we substitute in for 2 cos x, 225, and we are going to type that into the calculator. 2 cos 225, and that gives us negative 1,4142. So negative 1,4142. All right, now to find ML, we're simply going to take the, well, we can just go ahead and do exactly what they've instructed us here, to take this value we found and subtract this value. In general, we always take the top one minus the bottom one to find a distance. So always the top value minus bottom value. So this is going to be 0,55858 minus, and be careful, this is a negative value, so minus the negative 1,4142, and then let's type that in, minus negative 1.4142. So this gives us exactly 2 units. Then for the final section, the inequalities, the graphs of fx and gx are sketched below once again. Now the first example says for which values are gx less than 0. So what you need to remember is this notation. This notation represents y. So this actually just asks, where is your graph less than 0? For what y values is your graph less than 0? So over here we have gx being greater than 0, because this is obviously your y-axis, and this is where your y is positive. For these values on the x-axis, gx is equal to 0, and for these values, gx is less than 0. So if I focus on my graph, the g of x, we can see for any point here, like let's say this point, if you substitute in this x value, you're going to get a positive y value. If you substitute an x value here, you're going to get a positive y value. But for any x values between 90 and 270, whenever you substitute any of these values in, it's going to give you a negative y value. So for these x values right here, that's where your graph is actually where g of x will be less than 0. So we're going to answer it by saying from 90 degrees being less than x is less than 270, and this basically just means that x lies between these two values, because this value is always less than x and x is always less than this value. Now that's one thing. Now just for in case they would have asked, let's say they asked for which values of gx or for which values are gx less than or equal to 0, then your answer would simply have said 90 degrees is less than or equal to x, less than or equal to 270, because it's, if it also has an equal to, it includes this line over here, meaning this point will also be included in your solution. But yes, so now we just have less than, so we just have this as our answer. Then another type of question we can expect, for which values of x are f of x less than or equal to g of x. Now it has these two equations that we're comparing to each other, and when we look at this graphically, if I say f of x is less than g of x, it basically just means where is my f function lying below my g function, because that would mean whenever the function lies below the g function, it means the y value will be less than that of the g function's y value. So let's start here. If we see this is our f graph, then for all of these values, like the f graph is here, it's equal to each other, but here it lies on top of the g graph, so these values aren't applicable. Then here it crosses each other, so here they are equal again, but here the g graph is actually bigger than the f graph. So from 270 up to 360, the g graph actually lies on top of the f graph, which means it's bigger than. So, and in this question it says also equal to, so these 2 points at 270 and at 360, the two graphs are equal to each other, so those 2 points in this answer will be also included. So from 270 degrees being less than or equal to x, x being less than or equal to 360, that is where f of x is less than or equal to g of x. And once again, the easiest way to think about it is just to determine where does the graph lie below this graph, or if they said greater to, then you would just say where does the graph lie above the gx graph. Right, then that means we are done.